Welcome to lecture number 3. This lecture we will cover the problems related to ratio test and p-test. So this lecture is exclusively based on problem solving only. So the question is, determine the following series are convergent or not. The following series are convergent or not. Number 1, series 7 upon 2n square plus 9n plus 8. Let's see the solution. So here we clearly 2n square plus 9n plus 8 is always greater than or equal to n square for every n belongs to natural number. This is correct statement, because for any n this inequality holds. This would imply 1 upon 2n square plus 9n plus 8. When we take a reciprocal, the inequality will change. Now it will be less than or equal to 1 upon n square. Now we will multiply by 7. So this would imply, if I multiply by 7, then 7 on both sides, since 7 is non-negative number, so the inequality will not change. Now we can say, but we know that series 1 upon n square is convergent, because here the p value is 2 and by p-test it is convergent. So reason is by p-test. If the series 1 upon n square is convergent, then the constant time that series is also convergent. So this would imply series 7 upon n square is convergent. Why this is true? The reason is by algebra of series. So we could see that in the previous slide, this is my basically Bn, this is my An, and series Bn is convergent, because we have seen that series 7 upon n square is convergent. Series Bn is convergent, so by ratio test we can say that series An is convergent. By ratio test, series An, which is same as series 7 upon 2n square plus 9n plus 8 is convergent. Question number 2, series log n upon n. Our target is to check the convergence. This series look like follows: log 1 upon 1 plus log 2 upon 2 plus ... Log 1 is 0, so this is 0 plus log 2 upon 2 plus log 3 upon 3 plus dot dot dot. One should note that log of x is always less than 0 for all x between 0 to 1. Log x is negative between 0 to 1. So here log 2 is positive, there is no doubt about it. And log 3 by 3 is also positive. So log 2 onwards, they all are positive. This log 3 upon 3 will be definitely greater than 1. So log n is always greater than 1 for all n greater than equal to 3. This would imply log n upon n is less than 1 by n. Now we can take this as series Bn, and this we will assume as series An. This is an nth term of sequence series An. So see, this would imply series instead of implies, I should say. So we know that series 1 upon n is divergent because of P series test by P test. So if series Bn is divergent, then by ratio test log n by n is divergent. So by ratio test series log n by n is divergent. Question number 3. Check the convergence of 1 upon 1 plus 2 plus 3 plus dot 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 n. Solution. We know that 1 plus 2 plus 3 plus dot 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 up to n, this is nothing but n into n plus 1 divided by 2. So 1 plus 2 plus 3 plus dot 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 n, instead of writing that, I will say it is equal to n into n plus 1 by 2. So this would imply n into n plus 1 whole divided by 2. This is n square plus n by 2. This is definitely greater than equal to n square by 2. This would imply, if I take reciprocal, 2 upon n into n plus 1 is less than equal to 2 upon n square. Now you could see that this will form my sequence nth term of series Bn. So this is my Bn, this is my series An. And you could see that series Bn is convergent by P test. Hence, series 2 upon n into n plus 1 is convergent by ratio test. But series 2 upon n square is convergent by P test. So by ratio test, series 1 upon n into n plus 1, numerator will be 2, which is equal to series 1 upon 1 plus 2 plus dot 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 n is convergent. Question number 4. Series sine square n upon 2 raised to n. Solution. Sine square theta is always less than equal to 1. So sine square n is less than equal to 1. Now let me multiply by 2 raised to n. Since 2 raised to n is a positive term, So if I divide 2 raised to n, the inequality will not change, it will remain same. Now this will be my bn and this is my an. Now you could see that series bn is a geometric series with common ratio 1 by 2, which is less than 1, because we know that a geometric series is convergent if the common ratio is less than 1. So series bn is convergent by geometric series test. Hence series an is convergent by ratio test. So but series 1 upon 2 raised to n is geometric series with common ratio half, which is less than 1, implies series 1 upon 2 raised to n is convergent by ratio test series sine square n upon 2 raised to n is convergent. Question number 5. Series 1 upon n into nth root of n. Solution. N into nth root of n can be written as n into n raised to 1 by n. Now what I will do is as follows. I know that this n, which is can be written as 1 plus 1 plus 1 n times. This n 1 times is always greater than equal to 1. Now what I will do, I will raise by power 1 by n. So if I take power 1 by n on both sides, so 1 by n, here also it will be 1 by n, and here also it is 1 by n. But 1 to the power 1 by n is again 1 only. So what I got, n to the power 1 by n is greater than equal to 1. N to the power 1 by n is greater than equal to 1. That would imply n into multiply by n is always greater than equal to n. Since n is positive, so by multiplying, the inequality remains same. If n is negative, then the inequality will change. That would imply 1 upon n raised to 1 by n is less than equal to 1 by n. When you take a reciprocal, the inequality changes. Now this is my sequence bn and this is my sequence an, and I know my sequence bn is divergent by p test. See, because the value of p is 1, hence the series an is also divergent. So by p test, series 1 upon n is divergent. By ratio test, series 1 upon n to the power 1 by n is divergent. This ends the lecture 3.